On this display, there are 32 individual segments. The digits are comprised of 7 segments, and then there's a decimal point on each digit as well. Not having individually addressable power and ground for each segment helps to save pins on the inputs. These segmented displays have many different types, and a lot of them are different. So if you find a pinout diagram online, there's no guarantee that it's going to fit your display. So naturally, when you have 32 LEDs, you can save some space on the inputs by having them all share either the same power or the same ground. There will only be a closed circuit for current to flow when you address the segment that you want. That's exactly what these displays do. They're either common cathode or common anode, which basically just means common power or common ground. One additional measure in reducing the number of pins that is almost always taken with these types of displays is tying the common power and ground of the individual digits together as well. That's how these displays get away with only having 12 pins despite having 32 individual segments. If you're not sure about your display's pinout, there's a really easy way to test. Virtually all multimeters have a diode test mode function. It's usually under the ohm meter, but not always. You might have to press the function select to enter into the diode test mode. Once in diode test mode, your multimeter will automatically provide a safe voltage and current for you to test diodes on. Typically with these displays, there's going to be a pin for each digit and a pin for each segment. On my display here, you can light numbers by grounding the digits that you want to be lit and by raising a voltage to each of the segments that you want to be lit on all of those digits. After probing around my display and making a little diagram for myself to understand the pinout, I put it all together on this breadboard. You can see that because of the limited number of pins, your only options are segments to light and digits to light those segments on. I can't have the different digits display different numbers. Not in the traditional sense at least. There is a way around this which makes these displays significantly more useful, and I'll talk about that in a minute. Before I do, I also wanted to mention that these displays come with a little film on them. Typically, my first instinct whenever I see film on anything is to peel it off immediately, but some of these displays, especially the nicer ones, come with a high contrast film that helps you see the numbers better. I tested one of the displays that I hadn't peeled the film off of yet, and it didn't look like it had particularly good contrast. To test, I peeled off half the film, and it still didn't look that great, so I went ahead and peeled off the rest. Also, when you buy these displays, they're typically measured in fractions of an inch, which was kind of confusing to me at first, but this measurement is the height of the lettering. It's sort of a weird way to measure it because they could have different proportions, the thickness of the segments could be different, but it's, for whatever reason, it's the industry standard. Before moving on, I also wanted to say that this video is part of a series of videos where I make a YouTube subscriber counter using these displays. In my next video, I'm going to show you how you can fetch your YouTube subscriber data from the YouTube API using an ESP8266 microcontroller. I'll post all of the files and a detailed write-up for free, so if that sounds interesting to you, make sure to check it out. So how can you make these displays show different numbers on the different segments? That's kind of a huge deal. Well, if you have something to control the display like a microcontroller that can flip things really fast, you can use what's called persistence of vision, which is kind of like when the ceiling fan is spinning really fast and so you don't really see the individual blades, it's just kind of a big spinning fan. You can do the same thing with these displays where if you change the numbers fast enough, your eyes can't actually tell that numbers are changing and it will just appear as 4 numbers always on the screen. I've written some code that uses the Arduino IDE that I will also publish along with this video if you want to use that. That way you can use routines like activate digit, activate number, segments, that sort of thing to make it a little bit easier on yourself when you're coding. One question people commonly ask is, doesn't that wear out the LEDs faster, turning them on and off rapidly like this? You know, and that's typically true in mechanical applications. Your car starter will only get so many starts before it breaks. But in electronics, it's usually typically the opposite, which is kind of interesting. Typically with LEDs, if you have a 25% duty cycle, meaning that it's on for 1/4 of a second and then off for 3/4 of a second or something like that, you're actually greatly lengthening the lifespan of the LED. Also, in regards to earlier when we were probing our LEDs with the diode test mode on our multimeter, most multimeters will show the forward voltage on the display of the multimeter of the diode that you're testing. Remember that forward voltage is the absolute number of volts that are dropped as a result of this diode being implemented. It is therefore also the minimum required voltage that you will need to apply to get current to flow through the diode. Typically, the recommended operating voltage of these displays is not that much higher than the forward voltage. I think mine, the forward voltage was like 1.8 volts and the manufacturer recommended that I use 2.1. You do have some wiggle room here though, because typically with LEDs it's not so much a matter of volts as it is a matter of power. So you can typically raise the voltage as long as you ensure that not too much current is flowing through the diode. You absolutely cannot, however, lower the voltage lower than the forward voltage of the diode. Current just will not flow. If you're thinking to yourself, well, that's kind of a headache that you have to be constantly flipping the values on these displays to get them to light different digit numbers, there are also driver ICs that you can get for these displays that will do that for you. For electronics and IC questions, I love asking ChatGPT. I find that Google is good at finding the answers when you have a well-defined question, but ChatGPT is better at helping you define your questions. I'm not using a driver because in the future, after making the YouTube subscriber counter, I'm going to replace the display of that counter with a display that I made myself completely from scratch. Hence why it's important to understand how these displays typically work. Thank you very much for watching. Each of my social media channels have content that is unique to only that channel. So for more projects, tips, windmills, and shenanigans, make sure to check me out on Facebook, Instagram, and TikTok. Again, thank you for watching, and I hope you have a wonderful day.